Hi guys, welcome back. Today we are going to discuss the topic applications of differential calculus. I hope you guys have a basic idea of what is meant by differentiation, how it's carried out, and what are the differential outputs for different functions, basic functions. That means I'm starting off with the concept called finding the procedure for finding the maximum minimum of a given function. First, in the procedure, first take the given function f of x and find the f dash of x and equate it to 0 and find its roots. Then find f double dash of x. Then just keep these roots in this equation f double dash of x and check whether the f double dash of x is positive or negative. If f double dash of x is positive, then we have minima at that point. If f double dash of x is negative, then we have maxima. It's the procedure. That's it. Now let's look at an example. The example deals with a rectangular sheet of metal of length 6 meters and width 2 meters is given. 4 equal squares are removed from the corners. The sides of these sheets are now turned up to a form of open rectangular box. Find the appropriately the height of the box such that the column of the box is maximum. He is asking that just find the height of the box such that volume of the box is maximum. He is asking this such that whole volume will be maximum. If you remove a square strips from four sides which are of side, let assume them to be x from height of h, then we have to find the height of the original box from which the x distance is removed so that the volume will be maximum. Let us proceed. That the side of the square be x meter so that the height of the box is x meter and the sides of the base are 6 minus 2x, 2 minus 2x. How we formed it is just consider a square box over here which is of side x, x, and over here x, x. It's total 6 given the problem from this corner to this corner. Now we are removing x distance here and x distance here. Then the length of the box will become x minus 2x and the height is 2 meter. It's given in the question. Here we are removing 1x and here we are removing 1x. So the height will become 2 minus 2x. That's what we wrote here. Now just consider a unit length. Unit length, I mean, which is of length x into the paper so that we can find the volume of a box. Yeah, that's what we taken. X into x, 6 minus 2x, 2 minus 2x. It's the volume of an box. L into B into H, volume of a rectangular box. And we formed it as a cubic equation. Now we are finding the dv by dx. I mean, it's our function. Now we formed our function and finding the differentiation of that function f dash of x. And we found the f dash of x and we are finding the roots of that function. And the roots are turned out to be 2.2 and 0.4 meters. Now we are checking for f double dash of x, whether it is positive or whether it is positive or negative. Negative. For x d square, I mean f double dash of x is negative if x equal to 0.5. So we will consider as it is f double dash of x is negative. So the whole function is going to have maximum at this point. I mean x equal to 0.5, we have maximum volume of that given box. So 2 minus 0.45 into 2. 2 minus 0.9 something, 1.1, 5.1 into 0.45 into 1.1. If we do the multiplication of these three functions, we are going to get the volume, which is the maximum volume possible for the given conditions.